Perfect. So we are officially live, everybody. Hello and welcome to today's webinar. My name is Vilana and I'm the community manager of WeAreDevelopers. Sitting here in Vienna at home, I'm super happy to be part today and deliver together with Philipp this webinar to you, wherever you are. So as we're starting, I just want to mention a couple of house rules that we are having for each webinar. Please feel free to introduce yourself in the comments. On the right side of your screen, there is a chat function where it's on public. You can actually write where you're from, what are you doing, what's your favorite stack, which technology excites you the most. Just share some information with us so it can feel a bit more of a community here in this 1 hour that we're going to be together. Feel free to ask questions as well. Right next to the chat, you'll see a Q&A mode. There you can ask questions. Philipp will be taking them throughout the presentation and also at the end. He's really engaging and he likes to have an interactive session, so he'll be checking this section every now and then for the questions. If you feel that somebody wants to see that webinar but didn't sign up, you can send them the link right now and they can join us without signing up. So yeah, share it with your friends. Sharing is caring. And last but not least, our webinars also comply with our code of conduct. So please be kind, be inclusive, and respect each other in the chat section. If you see something that is disturbing, please let us know. You can write to me as a private chat, or my colleagues are also here to scout for inappropriate comments. And I do assume most of us know WeAreDevelopers because you're actually on this webinar with us. But just to give you a short overview of what we do, we have flagship events for developers throughout the year based in Berlin and in Vienna. Recently, we started these webinars as we had to cancel our event in Berlin to keep you engaged and to have the conversation going. And besides this, we actually have a job platform for developers. So if you're looking for a new opportunity or if you are looking for colleagues to join your team, go to wearedevelopers.com and check what we have there as job postings, or post your own job ad. Right now, it's for free. And yeah, at the end, we're going to have actually a small giveaway because we're still planning to have our event in Vienna at the end of the year. Let's see how it goes. Hopefully, it's going to happen. So at the end, we're going to have one small questions with giveaway in the chat section. So yeah, 2 people would win each 2 tickets for this event in Vienna. And yeah, now I think it's time actually to start today's webinar as more and more people are joining us. And yeah, Philipp, the stage is yours. If you don't know who Philipp is, actually, he's a developer advocate at Elastic. And in the past 10 years, he's been working as a web infrastructure and what else was it? The database engineer, as I read or as we talked. I want to mention everything that you have done. And yeah, he's super welcoming, super friendly. So make sure you ask him questions if you have any. I'll be muting myself and turning off the camera right now, and I'll be back later on. Enjoy, everybody, the next 45 minutes.
Thanks a lot. Hi, everyone. Let me head over to my slides. Before we start off, just to make this more interactive and keep the interaction flowing, if you have any questions, just type a Q and I will wait for a moment so you can actually properly type out the question. I'm not like 3 slides further. So if you have anything, just type a Q. I will try to keep an eye on that and we'll wait for you to type it out. Sometimes if I ask some questions about yes or no, you can just type plus or a minus, for example, just to say yes or no, which is normally the quickest way just to do some interaction. And with that, let's kick it off. Yeah, hi. I'm actually also based in Vienna, and for a change, I'm at home because normally I travel mostly throughout Europe, but I'm also sitting at home in Vienna. But in this new time, location doesn't really work. Your connection is very bad. I hope the connection is good for everybody else. So I'll continue with that. Yeah, thanks for the pluses. That works very well. So let's dive into from containers to Kubernetes operators and what we can do around that topic. So just one slide about me. Like I was already introduced, I'm a developer advocate at Elastic. I mostly talk about the good stuff that we do or general technology that we have. So let's see what we have here. If you've never seen any of our product, like maybe you have heard about the Elastic or the Elk stack, this is what it looks like. But I don't want to talk about too much of our products. Yes, my examples will be using Elasticsearch and Kibana mostly, but it broadly applies to anything that is especially close to a data store. So if you run any containers that are like a data store, this is what you want to see. So the obvious question is, who is using containers? And I'm expecting like lots of pluses now. I probably won't be able to count those anymore. You don't have sound. I think most people have sound, so let's keep on with that. If you don't use containers yet, don't be confused. This will be only on the conceptual level anyway, so you can pick this up as we go along. Probably if you don't have sound, refresh the browser. That's normally, have you tried turning it off and on again? Maybe somebody can type that in the chat box. So that people, yeah, whatever the solution is to get you going, let's do that. And then the next question I'm normally asking, and if I had a live audience, I would just wait for the hand raises, is like, who is actually using containers in production? And normally that's like 50% less or so who raise their hands at first. Many people are just using containers in development mode, but not for production. And then what is even less normally is people using stateful containers. So anything like a data store, like Elasticsearch, but could be also Postgres, MySQL, Redis, anything that keeps data. And that's probably still a lot because it's very convenient to get going. But after the initial phase, like especially going on in production, upgrade, scaling can be more tricky. And that is where operators will come into a little later. By the way, just out of curiosity, is anybody using our official containers? I've been a bit involved in building those. Yeah, anybody who does, I hope you're satisfied. Otherwise, let me know, like complaints in private chat and praise in public, please. So let's jump into the agenda. First, I want to talk a bit about Docker images, and we're always viewing that from the perspective of stateful Docker images. So anything in a data store. Then very short overview of Docker Compose and where it fits. And then we'll head over to Kubernetes, namely Helm charts and Kubernetes operators. So Docker, I assume most of you are using Docker and not some other container technology, but the actual right graphics for that one, if it loads, would be this one. And this is also the size of your average container nowadays. At least some of our containers are on the larger side, and it's, yeah, more the big bag shark, and we're all the little Nemo fish about to be eaten by that, unless you use Podman, probably for security reasons. So we have this internal saying that Docker is the most heavily funded college project ever. This was especially true like 2 or 3 years ago when they were breaking the APIs more or less frequently and stuff was not as stable as it is today. Things have definitely improved by now, but sometimes you run into fun or weird problems. And some of these problems we'll see a bit later. So the first thing that I think you need to just accept, or we as a company also accept, is that containers are the new zip format. Zip used to be the format to consume any software for probably the last 10 or 15 years. And nowadays, many people consume software in forms of a Docker container or any image. So if you want to provide any software, this is probably where you need to go. But for us, at least, it's just one of many options. We don't have a strong preference. I know that some companies, because, I don't know, maybe to be buzzword compliant, say like, oh, you really should run this on containers or Docker or Kubernetes. And for us, this is more of an implementation detail. So if you run it on Linux with the classic Debian or RPM, this is no shame. This is totally valid. Docker adds many cool new features, but it also adds new problems. And let's look at some of those problems as we go along. So the first fallacy or problem that we see every now and then is that people stop caring about security. And they want to run everything as root and all the permissions. So this is, I think, a kind of like fitting description of what many people do. You just need to replace the snake with the whale and Docker. And then you suddenly run all your processes as 777 and root again. And obviously this is not where you should end up, but it is something we see or get as a complaint every now and then. So for example, our containers are pretty strict about users and permissions. The Elasticsearch process, you cannot run it as root, like the process would just system exit if you try that. So we need a dedicated process to run it. A dedicated user. We have the Elasticsearch user with a user ID of 1000 and a group ID of 0. And you have to run it as that one. And then the permissions of your files and data directory need to match that, which leads to the common complaint that people open a bug report and say like, oh, this is broken, and suddenly I cannot have access my data because the permissions are broken. And what we especially like is when people write something like this. I prefer simple fire and forget Docker containers. And the way we always see that is this. And since this is a PDF export, my animated GIF is not working here, but you need to imagine Aragon running into the enemy and have the caption YOLO, because this seems to be what many people are doing with their data. And this is really not what we want to have with your data. This YOLO approach, like I prefer simple fire and forget containers, is not what you should do, because you should prepare for production and keeping your data around if it's any good. So so that you don't really solve the user ID problem. So if you start the Docker container with Elasticsearch and you bind mount the data directory, obviously you don't write your data into the container image, right? Because A, it would be gone if you replace or update the container image, and B, it will be very slow because of the layered file system. So you will bind mount the data directory, and then the process will write the data with the right permissions there, and that will work. The problem was mostly when people were either changing permissions on the bind mounted folder, or were trying to reuse an old data directory with different version of Elasticsearch that didn't set the permissions the same way. That was where people were mostly running into these issues. So if you don't manipulate the data directory, you will not run into that issue, but it's good to know how it works behind the scenes in case you run into issues. I hope that makes sense. Yes. So the data will be written by a specific user, and you normally don't have to access that unless you try to manipulate the data on the host directly, which you really shouldn't do. Then you might run into issues, but otherwise this will work fine. I hope that answers that question. Cool. The next problem that people sometimes encounter is that they want to have some host mutation, like changing permissions on the bind mounted directory, and you shouldn't do that, which leads us to the good old Unix philosophy that you need to know what you're doing and what file permissions are, because otherwise you will try to reinvent Unix and do probably a poor job. What about the backups of data? So generally, if you stop the Elasticsearch process, you could just snapshot or copy away the data directory. If you want to do it on a running Elasticsearch instance, the concept is called snapshot restore. That's kind of the way to do backups in Elasticsearch. You just do that through the API. What you would need to do is you would need to mount a snapshot repository, which could be Amazon S3 or a mounted file system that is available on all the nodes. And there you could put your backups or snapshots. But that doesn't really change with Docker containers. Yes, you need to make that accessible. So you would need to have the bind mounted directory for the snapshots, or mount Amazon, or have the reference to Amazon S3 to do the snapshot. But otherwise, that is just a regular database concept of making a backup. And you would just trigger that through the API. So while kind of like the file system parts might change a little, otherwise it's really the same if you run Elasticsearch containerized or not. Hope that answers that question. The next problem or fallacy that we run into quite frequently is latest. I'm not going to ask who is using latest because I don't want to see any pluses on that one. Or more specifically, latest on external dependency. Yeah, what about the bleeding edge? The bleeding edge is also prone to break. And let me get into why we don't think running latest in Elasticsearch is a great idea. The problem is if you go to Docker Hub, it implicitly has latest here, because if you copy this command, the docker pull Elasticsearch, it would imply latest. Does anybody know what happens if you do that and run this command? So this will fail pretty miserably because we don't provide latest. We just don't have a latest tag. And for us, this is kind of the right way to approach this. Let me explain why. Let's assume you stand up a 3-node Elasticsearch cluster today, and you're using latest. And in a year or so, you need more capacity. So you add 2 more nodes and you use latest again. Probably you're getting a new major version, and you didn't do or prepare a proper upgrade, and you might break your cluster in a weird or very unexpected way. And then you will probably come to us and complain that we broke your cluster. And we don't want that. And we don't want to destroy your data. So that's why we don't have latest. You will always need to specify the right version of the image that you want. So even when you change or add more nodes later on, you need to specify the exact same version, and then you're good. And we're good in production. It is slightly more work and maybe slightly annoying in development, but it will protect your data in production. And we try to be focused on production, because otherwise complaints, and we don't like complaints. What about having the major version pinned? So for example, could you specify, like, give me whatever is the latest minor version in 7, or give me the latest patch level version that is available in 7.6, for example? Do we provide those? No, we also don't, because that might lead you down another problematic use, where if you have a newer version and it might create data, it might not be possible to move the data to nodes with older versions. And then you might get an imbalanced cluster, and you will also run into weird problems. And like I said, make your life simple and optimize it for production, and you will have, or you will sleep much better at night. So we don't support any of that. You will need to specify the exact version number of our containers. Another thing that people want to have is runtime mutation. And when I say runtime mutation, I mean something like this. Like they say, oh, we should bind mount some shell script and it installs something. Or we provide an environment variable and then you install some packages through that, or whatever configuration system or scheme they want to come up with. Do we support that? No, because this would cause or would add the potential for trouble again. This is, let's say again, you have 3 nodes, and on 2 nodes, whatever you try to run here works on, and on the 3rd node, I don't know, you have a network connection problem, or the dependency you're trying to download is down, and suddenly you have different images, and your data might behave differently based on plugins that you install, for example, and it might work on 2 nodes, but it might fail on the 3rd node. And again, you would add this subtle error scenario that might be very hard to debug and make you very unhappy. So you should use the right container approaches here. So what we would request or recommend that everybody does is you use your custom Docker file. Here I'm installing some plugins. You install your plugins, you upload that to your own or a public registry with the image. And then wherever you want to use this, you just pull that specific image. So you have immutable images and you always use exactly the same image, so you avoid another error scenario. And this would be the proper way to handle stuff like that in Docker and not try to do weird installations when you start up the container. I know if you come from like classic server environment, you would just install stuff as you go along, but this is not really what you want to do with containers. So again, we don't support this and we definitely don't recommend it. Here would just be a very simple example of how to create a key store. A key store is like you want to keep some secret in Elasticsearch, like some credentials, for example. Would you bake those into the Docker image? No, those you would keep separately because they probably have a different life cycle. That would also include, for example, certificates. So anything that is around secrets or certificates, you don't want to bake into the images, because even though you might keep using that version of Elasticsearch 7.6, for example, for a year, maybe your TLS certificate ends before that and you need to rotate the certificate. But you don't necessarily need to rotate the image because of that. So those have different life cycles. That's why we would recommend not to bake in any secrets or certificates into the images, but just bind mount them. So here, this is the example of how to generate the key store with a Docker file. And then you could just bind mount them or could just load them here, for example, with a Docker Compose example, but Kubernetes supports the same thing. You can just load secrets and you could have a different lifecycle on those secrets other than on your Docker images, which will, again, make your life in production nicer. The next fallacy or problem that we see every now and then are base images. Does anybody feel very strongly about base images? Probably some people will say yes. Okay, I see a notice. So with base image, I mean, is it based on Debian, Ubuntu, some Red Hat, Alpine? And oftentimes this is very much a personal preference. So, okay, I don't use base images that are not created by yourself. Then you will need to rebuild your images yourself anyway, which is, by the way, a totally valid approach. Especially in larger companies, you often want to have the full control over that. So that is valid. You can see like most of the other stuff that we do, this is free and open code. So you can just see how we build our Docker images. You can just take that and put that on top of your own images. So you can go wild with that. I see Alpine. This is how we started with Elasticsearch like 4 years ago or so. Though at some point we actually moved away. So since 5.4, which was a long time ago, we have standardized on Centos. Before we had a mix of, I think it was Ubuntu and Alpine, but we ran into too many bugs and weird issues with Alpine, and then we stopped using that. And we have now standardized on one base image. Why Centos? Because most customers that we have are in the US and they often prefer or know something Red Hat based. So this was kind of the way of the least resistance. What kind of bugs while running into Alpine? I will need to dig up the specific GitHub issue. But if I remember correctly, it was always, so the main difference is rather than having glibc, which is old but very battle tested, MuCL is much newer and less battle tested. So I think it was, oftentimes stuff was very hard to reproduce. It was, if you run on Windows and you have more than 4 layers in the image, then you would hit a bug. So we had a couple of those that were very hard to reproduce. And while glibc is very ugly, it just worked. And we had far fewer issues than that. Given the Alpine bugs were fixed, and I'm sure Alpine has improved, but for us, this was just not the right trade-off in terms of stability. And like I tried to emphasize a couple of times, production and stability is where we try to be. We can dig up the specific issues afterwards. I remember 2 or 3 that kind of annoyed us a bit. For us, so far, since we're using Centos everywhere, what is nice is that they all use the same setup and they share the layer. So while Centos 7 is, of course, a large image, and I get why you don't want that, at least it's shared between all the tools that we release. So you only need that big base layer once, and then you have it shared between all of them. Also, as soon as you need the JVM, like for Elasticsearch, for example, even if your base image is only 20 megabytes, the JVM will still need 200 or whatever. So your images will never be super slim in the first place. And like I said, glibc was just more battle tested, which leaves us with the obvious downside of size. And I can see why people want small images, especially for stateless stuff that you deploy very frequently. But for example, for Elasticsearch, we're maybe more liberal around the size, because our thought process there is that you will probably put a lot of data on that image anyway. So if your image is 500 megabytes or 600 megabytes, probably won't make that much difference if you have 1 terabyte of data on that. Like the 100 megabytes there won't make much difference anymore. Also, you won't deploy that 50 times a day, because we only release every couple of weeks, like patch level releases, minor releases every 2 months or whatever. So you will not deploy that on a daily basis, like your own stateless services. There, the size might make a much bigger difference because you will push them very frequently, and network size, a new service. But for stateful stuff, it's probably less of an issue, or at least that's the thought process that we have here. That for stateful stuff, it's less important than for stateless stuff, because the deployment frequency will just be very different. Sometimes people ask about Windows-based images, because I think if you use a recent Windows Server version, you can skip that small VM layer in between if you have a Windows-based Docker image. Our team has very little Windows knowledge. Like, I haven't touched Windows in many years, and we try to avoid this for now. We might have some smaller images in the future, and we might use different base images for different tools, because the different tools might have different scenarios. For example, for Elasticsearch, we don't care about the size as much. But for example, if you have beats like FileBeat, like the lightweight agents or shippers that you deploy on many servers to ship data, there maybe you care much more about the data size. So their smaller images might make more sense. So we might move away from that single shared base layer image in the future. But for now, it's all Centos, but it might change in the future. Okay, so enough about Docker images. Let's very quickly do Docker Compose. I assume that most of you use Docker Compose, but for development or demo purposes, right? It's very quick and easy to stand something up. Like, this is at least my main use case, where I just have a demo, run Docker Compose, it's up and running, I can demo, I throw it away. It's not really a tool for production. I've seen people use it in production. I've even seen setups where people try to use it on multiple servers, but I'm not sure that is really what it was built for. This would, for example, be the simplest use case or simplest Docker Compose file that you could use to run Elasticsearch and Kibana together. So you can see I have at the very bottom the volume where I bind mount my data directory. You can see the Elasticsearch image, whatever version you're using. I give the entire container 1 gigabyte of memory and half of that to the heap for the Java process. And then I run Kibana next to it. I link them together and then they run. So yeah, if you want to have the Kubernetes experience, then of course Minikube is very nice for that. And we'll jump into Kubernetes in a moment. We used to have a demo setup with Docker Compose, but we had the feeling that everybody is moving to Kubernetes nowadays. So this has been deprecated and we're moving away from Docker Compose demos. So we will move as much as we can to Kubernetes now, which obviously leads us to Kubernetes. I guess most of you who use some orchestration use Kubernetes, and probably I'll get a lot of pluses, no? If you're using some other orchestration, what are you using? Oh, yeah, by the way, this seems to be the current mood. Whatever the question was, Kubernetes is the answer, which might be good or bad. Okay, Rancher, EKS, GKE, on-prem. Yeah, okay, 42 is, of course, also the right answer. Okay, OpenShift is a packaged Kubernetes, but it's kind of Kubernetes somewhere down there. Don't quote me on it, but that's the way I would see it. Is anybody using Swarm? Probably not so much, like since Docker has been bought and the new company that owns them, Mirantis, I think has been heavily investing into Kubernetes as well. So yeah, Ranger is also kind of Kubernetes. It's just like a packaged version on top of that. That's true. Anybody using Nomad from HashiCorp? No. Yeah, I also don't see that much. Mesosphere still, but that's probably also pretty much on the way out because not much support happening. So in the end, we are stuck with Kubernetes for better or worse. And in the end, it's a static configuration to deploy resources to Kubernetes. And you probably have seen this one way too many times, so I'll keep it very short. You have the thing that you interact with Kubernetes, where the biggest discussion is normally how do you pronounce it? Is it kubectl, kubectl, or whatever other variation you prefer? And I try to avoid that discussion of how to pronounce it. That thing talks to an API server, kubectl, yes. That talks to an API server that actually will do the work for you. It keeps its state in etcd. It has a scheduler and a controller manager. And then you have the kubelets on the actual nodes that do the work for you. This is the very simple architecture that you probably saw before. And what you get with that is YAML and lots of it. Who likes writing YAML? Okay, I would say I see mostly minuses, but a couple of pluses. I think those who write plus, that's the Stockholm syndrome, right? You get so used to writing YAML all day long that at some point you accept your fate and start liking it. Yeah, the discussion, what is better? JSON doesn't have comments. XML is, those who say that XML is made for humans and machines, I'm not sure what kind of humans those are, but it's not me because XML is not for my consumption. But that's a different discussion. Like for better or worse, with Kubernetes, we're also stuck with YAML and lots of it. Which leads me to this example. This is, by the way, from the Docker documentation. If you run this through a YAML linter, does anybody know what will happen here? So this is a port mapping. We're trying to map from the container to the host, port 80 to 80 and port 20 to 20. Yes, it's true. If you're using Python or Ruby, which are whitespace sensitive, you think that YAML is the right approach to be whitespace sensitive. If you come from the Java or C++ world or anything that is not whitespace sensitive, you think it's the devil and nobody should be using whitespace sensitivity. So that's true. Here, anybody knows what will happen when I run that through a YAML linter? Because something weird will happen. So what you get is this. And you probably cannot guess why. This is one of the weirdnesses of YAML. If you have the container mapping and that is lower than 60, it will assume that this is the base. So rather than having base 10, you have base 60. And that is why the mapping, port mapping of 20 to 20 will end up in this number here. You can try it out, run it through a YAML linter. It will obviously work if you quote the port mapping, but otherwise this will fail very weirdly. So be careful with that one. The other problem that we had, yeah, if you want to read up on the documentation, like this is where this up here, this is the link where this is also documented in the Docker docs. So it's one of the many nice features that you have there. Or if you have ever tried to have a list of countries and then you had AT and DE until you had Norway, which is no, which is I think one of the 13 ways of having truthy or falsy values in YAML. You learn your lesson and be careful with whatever you use in lists then. The other problem that Elasticsearch had with Kubernetes was that until 1.8, which admittedly was a long time ago, it didn't allow dots in environment variables. And we used those heavily. So we configured lots of stuff through environment variables and dots. And there was no real use why. Yeah, so this is why it makes sense that this number comes out. But this is probably not what you wanted. But yeah, good thinking, Arne. This is how it works. But it's probably not what you had or what was your intention there. So since 1.8, when this issue was fixed, we can use Elasticsearch and Kubernetes well together. And that led us to Helm. So if you've never used Helm, Helm is like a package manager. It supports templating. You can write your own templates and then fill them with the right values that you want to provide, which is nice because it just builds on the existing Kubernetes primitives. Like, once you know what a service, a stateful set, a deployment, whatever it is, you can just use those in Helm, and it's just a package manager that makes it easier to use that. And we have Helm charts, for example. They are currently still in beta, and they support a couple of products. So you can, for example, roll out the beats to run them, but you can also run Elasticsearch and Kibana through the Helm charts. They use a stateful set to keep the data, which is generally what most people do when they have any data or stateful stuff running on Kubernetes. And for example, for the upgrades, it would have a rolling upgrade and replace one node, upgrade it, reattach the stateful set to the new version, and then go to the next node until it has done the entire cluster. So it is very useful for anything that keeps data around. We mostly run this and try this out on GKE, but it should work on others. So we have examples from Minikube if you want to try it locally, and people have run this on other platforms as well. What is the difference mainly to the operator is that this one is very unopinionated. So it just exposes the environment variables, and you can mount your secrets, and it doesn't add much magic. It's just like, so the load shouldn't really make a difference. It's more like how opinionated or how deep your integration into the management of the cluster will go. You can spin up a large cluster, like you could spin up a 50-node Elasticsearch cluster and just run that. That's fine. It just gives you more flexibility, like you can use multiple upgrade strategies. You just configure everything like pretty much like you would with plain Docker images. It doesn't limit you in terms of scale. We will return to that opinionated versus unopinionated with the operator. This would be a very simple example. Like on top, you can see this is the Minikube example that you can use. This is where this is from. You just pull our Helm charts, and then for Minikube, you need to add 2 add-ons for the storage class, and then you can just run this. And yes, indeed, the colleagues opted to run this with Make because they're the old infrastructure hackers, and Make is still their golden standard. And this is what the configuration for this would look like. So this is what you would need to set. So for example, since we are using Minikube and we run this all on one node, we would set the soft Definiti so that we would have the primary and any replica copies of the data on the same physical node, which you would normally try to avoid. Like you would use different nodes, maybe even different racks, just to keep your data around, even if one rack fails. Not with Minikube. That's why we set the Definiti to soft. And then you can see, again, we set a very small heap. We set how much memory and CPU we're giving to an instance, and we also need to set the volume claim where to keep the data. All of this is very minimalistic to get you started. Obviously, you could scale this up to much larger instances and more instances, which leads us to operators. Operators are kind of the hot new thing that everybody wants to use, or many want to use. And they expand the Kubernetes interface and allow you to customize the management of your application. And they are actually written in code. So they are more work to create and maintain, but they will give you or allow you a more fine-grained control. Also, you have the reconciliation loop that we will get into in a moment, and how that works and why it works very differently than Helm charts. How you define what you want to have is you define a so-called custom resource definition, or CRD. And now you can think in terms of suddenly your Kubernetes cluster, once you add the operator, has an Elasticsearch or Kibana or APM feature that you can just use. So rather than being like limited to the Kubernetes primitives, you can now think in the terms of the service that you want to run. So it abstracts more away. I'm sometimes not very exact here between custom resource and custom resource definition. If you have done object-oriented programming, my comparison is always that the custom resource definition is like the class or the schema or the cookie cutter, and the custom resource is the concrete instance or the cookie that you cut out with the cookie cutter. So this is where what is the class, what is kind of like the definition, what is possible, and what is the concrete instance. CRD is the class, custom resource is the concrete instance that you can use. And then you have the custom controller written in probably Go, which is very common. That brings your resources to life. And this is the reconciliation loop that will run continuously, and it will basically check like, what do you have currently configured, or what do you want to have? What is currently running? And if the two are not the same, how do I bring the current state to that state that you want to have? And that continuously runs in the background. Whereas Helm charts are like a package manager, like you tell it, please install 3 Elasticsearch nodes with that version. And once it's done, it's done. Whereas the custom controller will run in the background and it will continuously check, okay, you have configured 3 Elasticsearch nodes, we have 3 running, okay, good. Then it will run another loop. You have configured 3 Elasticsearch nodes, oh, 1 died and we only have 2 Elasticsearch nodes. Let me bring up another Elasticsearch node that we are actually in that state that you wanted to have. So this is the main difference here. There was a community managed CRD, but the maintainer didn't have time anymore, so we picked it up. This is the logo if you ever run into it. I'm not even sure why this, but this is the logo that we have for it. You can find the code here. It's free code, you can just use it. It is unfortunately not called Operator, but it's called Cloud on Kubernetes, which always confuses people, but this is the operator code. And this runs all the server component of that we have. So it runs Elasticsearch, Kibana, and the APM server that we have. For now, more to be added in the future. It is actually written in Go. We use Kube Builder to interact with the Kubernetes API. With the custom resource definitions, and we use customize to make some customizations as needed. So for example, if you use a very old Kubernetes version and it misses some features, then we will patch together that to work with the very old Kubernetes version. That's where we use customize. So these are the 3 main components that we have in there. Yeah. I hope you hear again. And this is the way you can picture this. So first, our operator here deploys the operator. So we have now the operator is running on our Kubernetes cluster. So you have the controller and the custom resource definition that you can use. And then you configure the concrete instances that you want to have. So this one here, you say, I want to have 3 Elasticsearch nodes and 1 Kibana server running together. And this is what you configure here with your YAML files. And then the controller picks that up and checks like, okay, this is what you have actually running. Is this what you have configured here? If no, I will try to bring your state here into the state that you have configured. And it will continuously run. And the reconciliation loop, by the way, is stateless. So if it crashes, it will just restart later on, and it's no problem in that regard. So it will continuously check like what is currently running, what have you configured. If they're not the same, try to bring it to that new state. So you could, for example, say like add 2 more nodes or upgrade to version, whatever. And then the controller will try to make that change for you. And this one is, by the way, opinionated. So this has best practices encoded. So it knows how do you do an upgrade of Elasticsearch version this to version that. It is opinionated around security. So it will force you to have certificates. It will generate the certificates for you. It will generate passwords for you that you can then just extract and use. So it is opinionated in that regard, unlike the Helm charts. The Helm charts don't force you to use security. You can, but if you don't want to, you don't have to. Whereas the operator is opinionated and encodes best practices. Yes. So if you want to scale down from 5 to 3 nodes, the operator, since it's opinionated, will actually drain 2 of the nodes. It will pick 2 of those nodes. It will move the data off them And only once there is no more data on those two nodes, it will actually remove them. But this is, for example, built in. The logic, I'm not sure if there is a specific logic, if it knows who has the least data, but in the end, it shouldn't really make much difference. What is the important part is it will drain the data and scale down if that is possible. Yeah, this is actually, your question came slightly too early, but yeah, first it will drain nodes and then do that. Or for example, when you do an upgrade, it will make sure that when you do this rolling upgrade, you replace a node with a new version, the node and its data is temporarily not available. And Elasticsearch might think, well, we lost a node, and then try to reallocate the same data on a different node. But we would stop that during an upgrade process because we know that this is only a temporary thing and it would be unnecessary work. So all of this is built into the operator. Though you can still shoot yourself in the foot. So for example, if you configure 0 replicas and you do a rolling upgrade, a node will not be available and it will be gone. Okay. So to configure that in Minikube, this will need a bit more resources. This is what you would do here. And then you could just say like, this is the operator, this is the current stable one, but 1.10 will come out pretty soon. You add the operator, you can watch the operator come up, and then you can configure whatever you want in this YAML file here. Yes, the slides are available. I will post the slides in the chat at the end. And the next 3 slides will be what this YAML file actually contains. So this is the Elasticsearch configuration. And you can see here we have now an Elasticsearch API version or namespace in Kubernetes. So rather than Kubernetes primitives, we suddenly have Elastic concepts here. And then you can just have the kind Elasticsearch that you use. So this is kind of what the operator gives you. And then you can just say, okay, I want one node in this version with that much memory and this storage backend. So you can use those easily together. The stateless services like the APM server and Kibana are much simpler. You just need to reference them for where they store their data, and that's it. But again, you can see we have a service type Kibana and its own namespace. So this is the one you can use now. And you can just run that on Minikube. Since I said it will generate credentials for you automatically, the bottom command here is how you would extract the base 64 encoded default credentials that would be generated for you. So we generate them and then you just need to extract them, but it will be all done by the operator. Okay, if you make any changes in version or size of the cluster, change the YAML file, run kubectl apply, and the controller will, in the reconciliation loop, apply those changes for you. This more widely tested will probably add Pivotal Cloud Foundry soon as well. I hope that covers most of the use cases that you have. And again, this uses stateful sets again, but I don't want to dive into those because I've been going on for quite a while now. So where to keep your data? Persistent volumes are the default choice and what we would recommend either locally or whatever your cloud provider provides, like EBS on Amazon, for example. You can also use ephemeral ones like mtdir or host path, but that's more for like caching data or anything that might just disappear at any moment in time. This is probably less useful. In the future, we might add our own container storage interfaces, which is another Kubernetes standard. We'll see about that. What you will need to deploy CRD is cluster level privileges. That's kind of the trade-off that you have here. And in general, you have 2 deployment models. So you can either install the operator in its global namespace here. So this namespace here watches all the other namespaces and checks like, have you configured to have Elastic resources there? If yes, I will take care of them. And this will then take care of all of these. This has the advantage that unless you change into the namespace, you cannot accidentally delete anything from the operator. And it only runs the operator once, whereas the other deployment model would look like this, where you have different operators running in different namespaces, but only managing resources in them. This has the advantage that you could have different operator versions, but also that you don't need to give the operator global privileges, but you can limit it to one specific namespace. The downside is that these are totally independent clusters, and you could not then easily, for example, allow a cross-cluster search across clusters in different namespaces, which you could otherwise, because there is one operator to run them. However, the single operator will also not scale to, like, say, you want to have 50 clusters running. Maybe that's too much for one single operator to run. So there you might need to look into other approaches. There are many other operators out there. So operatorhub.io gives you a list of those, where you can just go wild. So you will need to check how each one works, since it's code and everybody codes something different. You will need to make sure that that works for your use cases. So to wrap up, whenever somebody says like containers are disrupting the industry, we're never sure if that people mean that in a good or a bad way. So sometimes it's, oh, you run everything as root and you write the data into the container itself, and then you have downtime because of that. So we're a bit skeptical of the disruption, or the good or the bad disruption, that you might have with containers. One question that many people ask is, can I run Elasticsearch on Docker and Kubernetes? And the answer to that is yes. But the question that you should actually ask is, should I run Elasticsearch on Docker and Kubernetes? And what is the answer to that? As always, it depends. If you run everything else on Kubernetes and you know it well, go wild. If you don't run everything else on Kubernetes, maybe not start with your data source there, because it might be very painful. I'll get back to the security question in a moment when we're done with the slides. Final thing that I call the Kubernetes Paradox, that I see every now and then, that when you get to somebody and they ask, like, do you have an operator to run your software? And we say, no, we don't. And then people were saying, oh, this is a blocker, we cannot use your software. And then you actually talk to them and say, like, oh, so you're actually running the majority of your workload on Kubernetes? And they're like, no, we're just in the prototyping phase. But it's still a blocker if you don't have an operator, which leads to the funny situation that you need to have the operator, and we have customers using it in production. But it's not like that everybody would run Elasticsearch on Kubernetes now or with the operator. It's still not the majority running it on Kubernetes. Helm charts and operators, I think it's mostly coming down to the opinionated versus unopinionated and the reconciliation loop, but we've spent enough time on that. If you want to have the slides, this is where you can get the slides. I can also dig up the link. So if you go to, I don't have the full URL, but if you go there, you will find the slides there along with many others. Now let me get back to the question. Do you keep up with security fixes on the different images? No. So for now, when you release an image, so you will have an image version called Elasticsearch 7.6.2, and this will never change. So to get security updates on that one, you will need to get whatever is the latest version that comes out, and then we will have updated any dependencies. One pain point that we have run into is that people run automated security scanners that will give them lots of false positives. Because just because there is some package in there doesn't mean it's actually exploitable. And scanners are sometimes going a bit wild. So we are right now looking into reducing the surface of these images and removing as many packages as we can, just to avoid the false positives from scanners, because those are a recurring pain point that we have been running into. But right now the images are immutable, and there's only the Elasticsearch or Elastic Stack version is in the image. You should not replace images without, or you would always need a new version number, but we don't have like new version numbers for old releases. So to stay current, you would always need to go to the latest version of Elasticsearch, for example. But we generally tend to be like, you should upgrade anyway, and this is the latest and greatest, so please upgrade. Maybe this is another reason for that. I hope that answered that question. Any other questions? So right now, you could write a Helm chart to roll out the operator. If we will do that, we're not sure yet. So far, our opinion is that it's simple enough to do that manually, so you don't need it. Maybe this will change. But you could have a Helm chart to roll out an operator. I see Martin is typing some more. I mean, Helm charts are definitely widely used, and they're kind of the simpler concept. They're also much simpler to create, by the way. So the Helm charts, I would say, are a half-person project, and the operator is a 5 or 7 person team working full-time on it. So the operator has much more power, but it's much more effort, right? But on the other hand, you shouldn't be scared of that. Actually, I think you should see it as an advantage, because then we do more work for you that you can just use rather than having to do more work for you yourself. The nice thing about the Helm charts, though, is that they're more generic. So if you need to run 30 different pieces of software, the Helm charts will probably be more similar to each other than the operators, which might all do different things. And you might need to invest more knowledge into knowing how each operator works. Whereas Helm charts are more like the generic solution that you can use. So if you have a requirement to run many pieces of software, Helm charts might be a nice option. If you want to go deep and have operational best practices and everything on Kubernetes, the operators may be the better choice. How many terabytes of data are lost in production due to failure of your operator? I haven't really seen much about lost data. Also, with the stateful set, since you can always reattach that, it would only hit you when you delete the stateful set, and hopefully you don't do that accidentally. So I haven't seen any really bad cases of operator failures yet. I hope we don't have them, but bugs happen, so I'm not sure. I'm afraid of stateful sets yet. Yes. So initially we tried to build our own stuff because we didn't trust stateful sets either, but that was a bit of a dead end, and it felt like we would re-implement 80% of what stateful sets were doing themselves. And if we do it ourselves, probably it's less tested and more buggy. So that's why we are gravitating towards stateful sets. And I think most people do that. And I think the big advantage of stateful sets are then the more people that use them, the better they should be. And also the more knowledge around them exists. So yeah, but that's a bit of a personal risk assessment and choice, of course, that you will have to take there. Okay, I see Mark is typing. Otherwise, thanks everybody for joining. If you have no more questions, have a nice evening. If you have more questions, I'm still around to answer.